Hi and welcome to Maths class. Today we're looking at probabilities on the normal curve. So we've already met the normal distribution curve and also a specific version of that, which is the standard normal curve, which has a mean of 0 and a standard deviation of 1. So what we're going to start doing today is looking at the probabilities that can be calculated on this curve, but most specifically some standard probabilities that are known and that we refer to quite frequently. So there you can see the normal distribution curve. This is just revision. We've seen this already. The mean is also the median and in fact also the mode, and it's the central peak. It's the x value of the central peak. And here I've got my 1 standard deviation, 2 standard deviations, 3 standard deviations. So whatever the standard deviation is for this particular curve, then that's going to form the scale for my x-axis. So what I want to do just for now is just talk about a standard curve. So if we want to make this into the standard curve, all I need to do is say, well, my standard deviation is 1 and my mean is 0. So this is going to be 0 here. This is going to be 1, 2, and 3, and -1, -2, and -3. So the first question I'm going to ask is, well, what is the probability that if I choose, if I choose a random value in this distribution, that it's going to fall in this green shaded area, which is basically within a distance of 1 standard deviation from the mean. Now, some of you may already have studied this in another subject and might know the answer, but what you may not have seen yet is how we come to that answer. So I'm going to show you what we do on our CAS calculator to work out these values. So I'm just going to pull up my CAS. Where is it? Click that button. Yes, there it is. And what you can see there, just a little reminder, that actually is the standard normal curve equation. So it's not the normal curve equation, which would need values for the mean and standard deviation. Mean is 0, standard deviation is 1, so those are known values. So this is my standard normal curve equation. And if you remember about any continuous probability distribution, then we find the probability of a value falling in an interval by calculating the integral of the function within that interval. So in this case, the interval I'm looking at is from x is -1 to x is 1. And I want to know the area under that curve because that area is going to give me the probability of falling within that range. So let's hit enter. Oh, hang on. Try again. There it is. Okay, so I'll just shift that for you slightly so you can see the whole thing. Not that we need all the decimal places, but it's roughly 68%, okay, 0.68, 2689, etc., etc. So let's just mark that on our graph. I'm going to call it 68.2. And I'm going to use percentages only because that is commonly what we do when we're dealing with these. Okay, so hopefully the next obvious question that's springing to mind is, what about in between 2 standard deviations? How significant is it to find out that, let's say I measure my height and my height is within 2 standard deviations of the mean? Maybe it's above, in my case, maybe it's below, right, for the mean. So let's make this a blue shaded region. So we get the idea that it's not just those end bits we're looking at, it's this whole region. Now, just by looking at it, you can see I'm actually shading almost all of the area under the graph. The area that's unshaded is this little patch down here on the left and this little patch down here on the right. There's very little that's unshaded. So between 2 standard deviations, let's grab my CAS again. Oh, I just realized you can still see that there. Sorry. So there's my blue shaded region. So if I go back to my CAS, and what I'm going to do is just change these values from -2 to +2. and let's see what we get. 0.954499 blah blah blah. So let's call it 95%. Well, let's call it 95.4%. But you can see the significance of this, that what I can now say about any value on the curve is that there is a 95.4% probability that a value will fall somewhere within a distance of 2 standard deviations, either above the mean or below the mean. Okay, let's use yellow just to get this last section. Now, in fact, really what's significant here, what I'm going to do with my yellow is show you that the only bits that will not be shaded now are these teeny weeny bits here. Everything else, if I'm talking about between 3 standard deviations of the mean, everything else is shaded. So it's going to be a big number. Well, it's going to be a decimal very, very close to 1, but still less than 1. So let's, oh, you can't see it. Let's turn it on and we'll do the calculation. Change my -2 to -3. Change my 2 to 3. Hit enter. 0.997. So to 2 decimal places, it would round up to 1.00, but it's not exactly 1. So let's go to 3 decimal places, 0.997, or let's call it 99.7%. So what have we actually calculated here? Basically, what we've worked out is that the probability that -1 is going to be less than x and is going to be less than 1 is 0.682. And sorry, I'm just going to get rid of that CAS button for you. Okay, that's better. Right. Oh, hang on. And I'm just going to change that to a capital X. Okay, so now let's look at blue. The probability that I'm going to fall within 2 standard deviations of, in fact I should call that a Z, not an X at all, because I'm on the standard curve. So that Z is less than 2. Apologies, that's a Z. Okay, so the probability of falling within 2 standard deviations is 0.954, and the probability of falling within 3 standard deviations, that's not even a 3, I'm doing well today, is 0.997, which I go to 3 decimal places for always, because otherwise it looks like it's 1, and it's not, it's less than 1. So these are known values that you are expected to have a pretty good idea of. We need to know 0.68 and 0.95 and 0.997. So I'm just going to, it's not what I want. This is the one I want. Okay. So what we have here is a summary of this, and this should be in your handouts. Common probabilities associated with a normal distribution. 68% of values will fall in between 1 standard deviation, 95 in between 2 standard deviations, and 99.7 in between 3 standard deviations. And that's what that looks like here in the diagram. So you can have a look at that for yourself. So what I'm going to do now is I'm going to just talk a little bit about standardizing, which is where I move my values from the normal curve onto the standard normal curve. And one of the reasons I might do that is I want to work out how close I am to these standard probabilities that I know. So let's just have a look at that. All right. So if I have my standardized values, then it converts my normally distributed data to a set of units which describes the number of standard deviations each value lies from the mean. So I've got my normal data, which describes the actual distance that each value is from the mean. So I might have a value that has a mean of 100, and then I might have a data set which has a mean of 100 and a value which is 110. That is a distance of 10 from the mean. Now, if I find out that 10 is my standard deviation, then that becomes a standard value with a distance of 1 standard deviation from the mean. Okay, so I put my x values in terms of standard deviations. So when I standardize my value, that's what happens. So we call these z values, and this is the calculation we use. So this is a really important formula for you. Z equals x minus mu over sigma, where mu is the mean and sigma is the standard deviation. So if I do my calculation and I end up with positive positive z values, that means my original value is above the mean. If I get negative values, then it's below the mean. So let's do a simple example here. IQ has a mean of 100 and a standard deviation of 90. So what if I find out that someone has an IQ of 90? Where does that put them on that normal curve? All right. So let's change that to a z value. I'm going to have 90 minus 100, which is my mean, divided by my standard deviation of 15, which gives me negative 10 over 15, which is the same as negative 2/3, which is, oops, that doesn't look like a 3, which is negative approximately equal to negative 0.667. So ignore the fact that that looks very similar to our 68%. It's got nothing to do with probability. This is my z value. So if I go back to my graph and I think about where that would be on the graph, negative 0.67, that value is going to be negative 2/3 from this mean here. So it's about there, negative 2/3. All right. So an IQ of 90 is here on the curve. It's quite likely to occur, assuming that those values that I just gave you for IQ are true. I don't know that for a fact. It might feel like it's less than the mean, but actually, if you look at the range, most of your numbers are going to come in this range. So the IQ we've just calculated has a z value of negative 2/3, which puts us exactly there. Okay, and that is all that we're going to look at in this video today.